going to talk about subprograms. Subprograms are also called procedures, subroutines, modules, functions, or routines. The idea is to break your program into smaller parts, letting you group related instructions in one place, making your main program smaller and easier to read. As your program gets larger, it can start getting messy. Breaking it up this way helps keep it clean and manageable. So rather than struggling with a single large program, just write a bunch of small programs and put them together to create the larger program. A subprogram is a small part of the program that solves a single task. A subprogram could even be broken down into more subprograms to make sure each one only has a single task. Many languages call subprograms functions. I will refer to them as functions from here on out. Perhaps you need to run the same set of code at different times in the program. You can run the function instructions over and over again. This reusable feature is also a great benefit of the functions. So not only do functions make writing large programs easier, but they also make a great spot to put code that can be called from different locations in the program. So any part of the program can call the function and run it at any time. No matter what programming language you're using, the basic idea behind a function is to define the function by name and add it to the code. You want it to add the code to it that you want it to run. Then, when you need to run the function code in the function, you call the function by name and it will run. So the functions will never run unless it is eventually later called in the code. The name you give the function should be meaningful, just like variable names. They should describe what the function is doing. For example, in a game, every time the user presses a certain button, their player jumps. This could be a call to a function that runs code to make the user jump. It can be called again and again every time the user presses the button. You might have a function that checks if the username and password are correct as the user logs in. This would take the user's input and check it against a database for current usernames and passwords. Here's an example of syntax for different languages of a simple function that lets your user know that an error has occurred. JavaScript reads function show error, empty parens, opening curly brace, alert, inside parens and quotes, an error has occurred, semicolon, closing curly brace. Then show error, opening and closing parens, semicolon. Swift, function show error, parens, opening curly brace, print, an error has occurred, inside parens and curly brace, or parens and quote marks, ending curly brace, show error, empty parens. C++, in this example, void says it's a function that doesn't return a value. It says void show error, empty parens, opening curly brace, see out, an error has occurred, and closing curly brace, show error. PHP, function, show error, empty parens, opening curly brace, echo, an error has occurred in quotes, semicolon, closing curly brace, show error, empty parens, semicolon. At the simplest level, a function can do the exact thing. I'm going to go back here. At the simplest level, a function can do the exact same thing every time it runs. As these functions show, it displays a generic error message on the screen whenever an error occurs. However, lots of different errors can occur, and you'd like to be more specific for your user. You could write 20 different functions to display each type of error, or you could write a single function that accepts data like what type of error occurred, and that one function would then be able to handle displaying all 20 different types of errors. And you as the developer only had to write one subprogram or one function. So here we see function, show error, and now inside the empty parens we have a parameter by e, and then open curly brace, and then alerting out, and then concatenating e to show the type of error, and then the words error has occurred. And then below it has the call show error with sending in an argument of e, which is the type of error there was. So here we can see that an e represents the specific error that occurred, and if we send that argument along with the call to the function, it can be accepted as a parameter and used in the function to make the error message much more specific depending on what the error was. Different inputs can go into a function, and it can even return a value back to where it was called or run from in the code. Say your program has a calculator of some sort, like letting the users calculate their square footage of their rooms for carpet. The user can use this calculator again and again with different numbers, and the same function will run with the same code, but just using different input values from the user. But as a programmer, you don't have to rewrite a different set of code for each time the calculator is used. Pseudocode for the calculator might read something like this: get user input on dimensions of the room, call the subprogram that will calculate the area of the room, return the area value, and display it for the user. Here is a simple subprogram or function by the name of area that is called using JavaScript. It follows the pseudocode but looks very different. It says function area, and in parens a comma b, opening curly brace, return in parentheses a times b, semicolon, ending curly brace. Var length is assigned prompt, length of room inside quotes and parens, semicolon. Var width is assigned prompt inside parens and quotes width of room, semicolon. And then document.write inside parens area, and then inside another set of parens length, comma, width, ending with semicolon. So let's go over what is happening here. In this code, the function is written before it is even called or run. It won't run until it is called by name. So we see a function being set up by the name of area. It will accept two parameters, a and b. Using those parameters, it will multiply them together and return the multiplied value to wherever it was called. But remember, this function won't run just yet. We need to go down to where it will be called in code later for it to actually run. Later in the code, after the function, we have set up two variables by the names of length and width. They are both assigned values from the user. Let's say the user entered 8 for the length and 5 for the width. Below that, we see that we want to display something on the screen. Document.write will display to the screen. Inside the parentheses after document.write is where the function will be called. Area is the name of the function. It calls the function and has those two parameters that it will send with the call, length and width, which contain the values the user input, 8 and 5. At this point, the function actually runs. Even though it is above the call, the program knows to go to the function at that point. Remember, length is assigned 8 and width is assigned 5. So those two values are what are being passed in as arguments with the function call. Now the function runs and the arguments of 8 and 5 now get assigned to the parameters a and b in the function. They are multiplied together to get 40, and that value is returned right where the function was called, and 40 is then written to the screen with document.write. Here's another function receiving two values. This time, the two values are simply being added together. But This time we're showing C++ code that adds these two numbers together. It reads int, add numbers, inside parens, int a, comma, int b, opening curly brace, int result, semicolon, results assigned a plus b, semicolon, return result, semicolon, ending curly brace. Sum assigned add numbers, inside parens, n1, comma, n2, semicolon. With this code, the add numbers function doesn't run until it is called by name below the function. Two values that the program already has, n1 and n2, are used as the arguments to send with the function call. The function add numbers then runs, and the values of n1 and n2 are now the parameters a and b. A result variable is set up and is assigned the value resulting in a and b being added together. This value is then returned to where the function was originally called and is assigned to the variable sum. Here is a more real-world kind of example. Say you have a shopping cart in your system that you've coded. If the customer has spent over $50 on the amount that they have in the shopping cart, they're going to get free shipping. So the total they spend will remain the same if they spend over $50, but if they spend under $50, then they have to pay shipping. The shipping would be 5% of what they spend, let's say. We would need to add this to their amount. So we want to then let the customer know what their total will be after this is calculated. This is a great use of a function because each time the function is called, the user amounts can be different. They could also go back and add an item to the shopping cart to get their total over 50, and then that same function would be called again with a different total being returned. So let's take a look. It says a function is called getTotal, and it has a parameter inside parens amount, opening curly brace. If inside parens amount is greater than 50, and then curly brace, total is assigned amount, ending curly brace. Else, opening curly brace, total is assigned amount plus inside parens amount times 0.05, semicolon, ending curly brace. Return total, semicolon, ending curly brace. Get total, inside parens 75, semicolon. So here we can see that the getTotal function won't be called again until at the bottom there it actually calls it by name, getTotal, sending in the argument of 75. Then the function getTotal will actually run, the 75 being passed in as the parameter now amount, so amount now holds the value of 75. So it goes to the if statement and it asks the question, is the amount over 50? And in our case that is true, so the curly brace before the else will run and it will assign 75 to be the total without adding any extra to it. And then it will jump down to the end of the if and ignore the else because that was not, it was true and not false. And it will then return total to the same spot that it was called. At this point, it's not being assigned to anything once where the call was made, but that is what's going on with this shopping cart example. Now, for practice, let's take a hands-on example, and let's try to figure out pseudocode for miles per gallon. This function will divide the miles by the gallon and return the answer and see what you come up with on your own for this one.